So Hess's law is, to me, kind of like a puzzle. And if you practice them enough, they'll stop feeling annoying. But it's all about making sure to understand the method. So I'm going to try to make sure and walk you very clearly through the method. And maybe at some point you'll think they're fun and they're kind of like doing puzzles. They check themselves. And that's one thing I really like about Hess's law. Hess's law says two things. The first is that you can reverse any reaction as long as you change the sign of H. So notice in this one I have A plus B goes to C, and I have this is the delta H. If I wanted to reverse it, and notice now that means that my C, that was a product, is now a reactant, and if I wanted to turn it back around, I change my sign. First rule. Understand that? So if it's going forward and it has one delta H, if you flip the reaction, so the products are now the reactants, you have to flip your delta H. So that's the first rule you know. Second rule, you can multiply or divide all the coefficients in a reaction by the same number. You can't pick and choose. It's got to be by the same number, as long as you multiply or divide the sign of H by that value. So notice here, these are all ones, and so that's just the normal value. If I make them twos, then I have to say this number times 2. What if I wanted to make them halves? What if I made 1/2 A plus 1/2 B goes to 1/2 C? What happens to my H of reaction? It's 50 times 1/2, or half of 50. So be nice and clear on those ideas. So you can reverse it, and if you reverse it, flip the sign. And you can multiply or divide by any numbers, fractions, whole numbers, as long as you do it to everyone, including delta H. So here's the method. With Hess's law, we have H of reactions for this and for this. So we have an H of reactions for both of them. There's a third principle, is that when you combine reactions, and you can do it, things on the opposite sides of arrows, I'm going to get back to these first two steps. I'm going to repeat this, but things on the opposite sides of arrows cancel. This is the same things. So notice that like AB, see how they're opposites? Like AB is a product and the other one is a reactant. Those cancel. Also notice that, like, do you see the B here? It has an opposite and it cancels. Things on the same side add. So notice that I have an A and an A. So this reaction overall is 2A plus C goes to A2C. I'm going to repeat one more time. So when you're solving reactions, and you can have more than two, you can have multiple reactions, but as long as you have the same amount, like if this were a 2, I would only be able to cancel out and make that a 1. So this guy cancels with this guy, and then this guy cancels with this guy. I do have an A on this side and an A on this side. Those are on the same side. So this cancels, that cancels, that cancels, that cancels, and then the ones on the same side add. If we can make it so that these reactions match up and we get what the question asks us to get, the question will give us an equation, and we're trying to make an equation by adding or subtracting and multiplying, whatever we're going to do. We're trying to make an equation that matches what the question is giving us. So whatever we have for our H's, you can also add all the H's. If one is negative and one is positive, you would still, add. It's just like saying adding a negative. You're going to be given something called an overall equation. And we're going to go ahead and look at this first problem for the example. So it says find delta H for this. This is the overall. This is what you have to find delta H for. So you're going to be given an overall. You're going to start on the left side and check that things in the lower reactions are in the right places. So these are the two lower reactions. So we're going to just see if things are in the right places. You're going to work your way to the end, but ignore things that appear in 2 or more equations. So let me show you what I mean. Start on the left. So here's iron, and iron only appears right here. Nowhere else. He's in the right place. So now we're going to go to the next one, chlorine. Oh, chlorine appears in 2 reactions. That means that we skip it. Now we're going to go to iron trichloride. Oh, cool. He is in only 1, and he's in the right space. Great. That's our first step. We've done the first step. Secondly, Start on the left again of this overall equation and fix any coefficients. So fix our iron's coefficient. Well, he's 1 and he's 1, so that's great. This is the easy example. And then notice we skipped the Cl2, and now we're going to make sure, is he 1? He's 1. So we're good. So let's see, once we've done that, we're going to solve it and see if our answer that we're going to get here matches our overall. That's the point, is you're supposed to get something that matches. So again, I'm going to add and cancel. Notice that I have this on this side and this on this side. So those two cancel. So I have iron solid plus, now what's 1 chlorine plus 1/2 chlorine? Well, you could say 1 1/2 if you wanted. In chemistry, we would probably say 3/2. Chlorine goes to FeCl3 solid. Now, this is where we're checking. Is that this equation up here? Oh, yes, it is. So we've done a match. This is the whole self-checking part. Once we've made a match, we can just add up our H of reactions. So this is saying that you take this number here and you're going to add it to this number. And when you do, you get the 399.5. Let me show you the next one. So this is our overall reaction, and we're going to just follow our steps. We're going to start on the left of the overall equation, C. Here's where our C is. So our point of this first step is to get everything in the right place. He's not in the right place, so we're going to use the principle that we used above. We're going to flip the reaction. I'm going to flip it over here to the right. When you get good at these, you'll just flip it just above it. Now what happens to my H when I flip it? It becomes negative. I've got them flipped, so I'm good to go. So now my C is in the right position. Now I'm going to go over and I'm going to check for my CO2. Is my CO2 in the correct position? Yes, it is. Now it's better to have these lined up, especially your first few times doing this. So I know it's a pain, but go ahead and just rewrite it if you didn't have to flip it. And just be happy that you didn't have to flip it. And since we didn't do anything to him, our H stays the same. Now for the second step, we need to check those coefficients. The C should be a 1, the CO should also be a 1, and those check out correctly. Now solve. First, do your cancel, so our CO gas cancels with our CO gas. And then we add the things that are on the same side, so a half of an oxygen plus a half of an oxygen gives you a full oxygen. This gives us CO2 gas. Does that match this? Yes. If it matches, then you can just add up the delta H's. Notice that they're both negative. So you can add both of those numbers and you're going to get the negative 394 kilojoules. I have one correction on the next problem. You can see how I'm about to change one of the numbers in front of the oxygen to a 1. Do problems 3 and 4 and come back and check them.